Sharding and partitioning are important key of distributed system. This helps us to improve the throughput, overall throughput of the database and also availability of the database. Okay. So in this video, we are going to understand what is sharding, what is partitioning, understand the difference between sharding and partitioning, when should we do sharding and partitioning, okay, and how it is evolved basically. Okay, so cool. Now let's continue, and we will also see the advantages and disadvantages of sharding and partitioning. Okay, so let's say you have started a startup, okay, and this is the application server. Okay, this is the application server, and this is the database. Okay, and this database is on top of a EC2. Okay, and you have taken a small EC2, small flavored EC2, because obviously it's cheap. Okay, and this EC2 can only have let's say it can only have 100 GB of data. Okay, and it can only take like 100 writes per second. Okay, cool. So your startup is running well, you got lucky, someone popular came. Okay, someone popular came and tweeted that yeah, this website is good. Okay, so when that someone popular came, you got more clients. Okay, you got more clients. Now what happened, that you have seen the amount of data which is stored in your EC2 is becoming less. Okay, so now you have like total of 200 GB of data, and the write throughput has increased to, let's say, 150 write per second. Okay, now what can you do? So what have you done is that so this is your again application server. Okay, so these are like lots of client. Okay, so what you have done, that you have increased the flavor of the EC2. Okay, so you have increased the flavor of EC2, and the DB now becomes like, let's say 1000 GB. Okay, and the write throughput is, let's say, 1000 write per second. Okay, cool. So when you increase the flavor, or like you increase the hardware of the database or of an instant, that thing is called vertically scaling the database. Okay, that we call vertical scale of database. Cool. Now what happened, someone like now people have started using your app even more and more. So what you have seen, that this 1000 writes per second is becoming less. So what you did, so till now we have understood about replication, correct? So what you did, that this is the application server, and you have made two EC2 in which the DB is present. Okay, and all the writes are inside this DB. All the critical writes are inside this DB, and all the reads, actually all the reads are happening from this DB. Okay, all the reads are happening from this DB. So again, your throughput has increased and you have replicated the data. Okay, now let's say what happened, that Virat Kohli came and he told, whoa, what a product, I like this product and blah 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 things. Okay, now what happened, you got even more customer. Now there are like 1 million customer, 1 million customer. Okay, and you need 1 million GB of data, and you need like, let's say, 1500 write throughput. Okay, write per seconds. Okay, now you went to Amazon Web Service panel, and you have tried to scale your EC2 instance even more. But now what you have seen, that you have hit the maximum amount of hardware you can use. Okay, so you cannot vertically scale the data anymore. Okay, so now what can you do? So that is when what you did, that you partitioned the data. Okay, so what you told, that all the user, so let's say the total data is, let's say, 1 million GB. Okay, 1 million GB. So what you told, that 0.5 million GB will be in this database, and 0.5 million will be in this database. Okay, 0.5 million will be in this database. So your application server is here. Okay, half is here, half is here. Okay, and due to this, what also happened, that let's say you need 1500 write throughputs, right? Now as the data has been divided, so now in each EC2 server, we are only getting like we are only utilizing 750 write throughput, write per second, correct? So you have distributed the load from each EC2 instance, okay, from each EC2 instance. Obviously, now what can happen that in this partition where 50% of the data is present, okay, and also there is another database in which 50% of the database is present, okay, this also have its own replicas, okay, which are used for only reads, and all the critical writes are happening in this main database. Okay, so writes are happening in this database and reads are happening from the replication database. Okay, and this is your uh, application server. Cool. So this is how we came to the complexity of partitioning. Okay, so this technique in which you are dividing the workload basically between multiple machines is called horizontally scaling up. Okay, so previously when we are increasing the hardware, where we were increasing the CPU, when we are increasing the RAM, it is basically vertical scaling. When we are increasing the number of machines, it becomes horizontal scaling. In industry, basically the practice is managing more horizontal scaling than vertical scaling, because horizontal scaling is more scalable. Okay, so basically what we did, we sharded the database. Okay, we sharded the database and we partitioned the data. Okay, we sharded the database, we partitioned the data. So commonly people actually interchange these terms, but sharding is basically in database level and partitioning is basically the data in the data level. Okay. So let's say, okay, you have 100 GB of data and due to some reason your software cannot handle like 100 GB of data at a time. Your software cannot like search 100 GB of data at a time. So what you did, you partitioned your data into multiple parts. Okay, so you partitioned your data like 30 GB, 20 GB, 10 GB, 20 GB, 20 GB. Okay, but no one is stopping you to like have this data in one database. Okay, so what you did, you put this 30 GB into this database. Okay, and you also put this 10 GB in this database, and you put this 20 GB in this database and 20 GB in this database and 20 GB in the database. Okay, so you partitioned this data into this like 30, 20, 20 GB and you kept them in 2 DB. So basically you sharded the data into two device. Okay, so what we can say is that we have 5 partitions and 2 shards. So whenever a request comes, let's say someone asks for a data, so first you have to know, so let's say this partition is A, B, C, D, E. So first you have to know your data resides in which of this partition. Okay, once you know your data resides in which of the partition, okay, then you go to this particular shard and get the data. Cool. Now, how will you know that which partitions contains the data? Or like what are the techniques in which you can partition the data? So one way how you can do this is, so one way is like, let's say you are storing all the names of the people who are working in a company. Okay. So what you did, you partitioned the data according to their name. Okay, so every person whose name is starting from E to A to E, you have partitioned in partition number 1. Everyone whose name is starting from F to K, you have partitioned in those data is in partition 2, and so on. Okay, so whenever let's say someone is searching for my name, Akash. Okay, so Akash should be present in which partition? It should be present in partition number 1. Someone is searching for, let's say, Ketan. Okay, so where should it be present? It should be present somewhere in like E to K, right? So F to K. So F to K is in partition number 2. Okay, so this kind of partition where we have a range. Okay, so therefore it is called range based partitioning. Okay, therefore it is called range based partitioning. So what are the pros and cons of range based partitioning? So let's say you want to search all the name who is starting from A to, let's say, F, okay, or let's say from A to H. Okay, so what you know, that all the name who are present in A to H will be in 1 comma 2 partition. So you can just do a range query and get all the names. Okay, but what is the demerit of having range based query? Range based partition is that, for example, in India there are lots of names starting with A. Okay, there are lots of names starting with, let's say, uh, K also. Okay, but there is very little names which are like start with X or Z. So this particular partition will be almost empty for the whole year. Okay, so this resources will be useless for whole year. Okay, and all the traffic will only flow to this partition. So this particular DB will get lots of like writes and reads, lots of traffic, and this anyone whose name is starting with A to E, their database operations will be always so slow. So basically, the benefit is range queries, okay, range query, but the demerit is hotspot, hotspot. Okay, so how can we get out of this? So second is hash hash ranged based partitioning. Okay, so what happens in this? So your name will be, so for example, if you are storing all the name, so your name will be passed through a function. Okay, so let's take all the name which are starting from A. So f of Akash can be 150. And where is 150? Basically, it's in this partition. And let's say this is partition 2. Okay, so this is 1, 2, 3. So this is 3, this is 4, this is 5. Whereas f of Anushri, it's 370. So where can 370 be? 370 will be somewhere here. So it's in partition number 4. Whereas f of Ashwin is 410. So where can 410 be? It's in partition number 5. Okay. So we have kind of solved the hotspot problem, but let's say f of Messi, okay, Messi is, let's say, 270. Now everyone is going to the database and searching for what happened to Messi, what happened to Messi, and this particular partition, which is like third partition, got extremely overwhelmed. So again, the hotspot do exist if some popular kind of names are there, but if there is like less frequency of a name, then in that case the hotspot has been decreased. What is a better solution? Obviously we will learn about that in the upcoming videos, but this is how like we can do the easiest way of partitioning. Also you can take this part also. So in previous video we have learned about like column oriented database, row oriented database. So partitioning can also happen according to that. So basically, like, there can be horizontal partitioning, which basically happens in row level or document level. Okay, and vertical partitioning, which is vertical partitioning, which happens in column level or table level. We will learn about this in future videos anyway. So let's see the advantages and disadvantages of partitioning and sharding. Okay, so let's say at the initial phase, you have you have your database which is not partitioned or sharded. Okay, so it is extremely easy to maintain, to develop such kind of databases. Cool. But then you partitioned your data inside one database. Okay, so basically this is what you can say logical partitioning. So in this partition you have all the data from 1 to 50, and in this partition you have all the data from 51 to 100. In which kind of cases this actually occurs? So let's say you have a database. Okay, let's say you are storing a lot of files. Okay, so this is a big server and you are storing a lot of files. Okay, you are storing a lot of files. Now if you want to read a particular file, you have to search linearly, like, is this file the one which I want to read, is this file which I want to read, is this file which I want to read, which can be extremely tough. So what happened, that you maintain a metadata. Okay, you maintain a metadata, okay, in which the, like, uh, you maintain a table basically in which there is a metadata of each files. Okay, so you maintain a table in which there is a metadata of each files. Okay, but due to some problems, the metadata size cannot exceed more than, let's say, 100 rows in a table. Okay, so what you did, and you have like, let's say, 30 files. Okay, so what you did, you created three tables. Okay, and in three tables, in this table you contain all the files from 1 to 10. I mean, you contain metadata of all the files from 1 to 10. You contain, in this second table, you contain all the metadata for files 11 to, like, let's say, 20. And in this one, you contain metadata of all the files from 21 to 30. Okay, and again, what you did, like, this three tables metadata is stored in one table. Okay, so in this kind of scenario, like, we have logically partitioned the data, but we have not sharded the data. Okay, but this comes with an complexity. The complexity is, like, data from 11 data of 11th file should not be here. So this metadata should be extremely, like, they should contain the data, like, very properly, or else what will happen, that it may happen that 11 file came here and, like, ninth file came here, then all the data is screwed up. It, like, what I'm trying to say, it's complex. Okay, so what I'm trying to say, that it is complex. Then the third thing is, like, you have sharded the data, but you have not partitioned the data. So basically, your data is not divided, but you have two storage system. Okay, so you have two storage system, but your data is same. So what do we call it? We call it replication. So basically, if there are multiple shards, but there is no partition, then it is called replication, basically. And then the fourth case is, like, your data is partitioned and your data is sharded. Your data is partitioned, then, and your data is sharded. So now basically the scenario what we were understanding, like, 0 to 10 is in this database, and, like, 11 to 20 in this database. Okay, so these are, like, different scenarios of partitioning and sharding. Okay, so let's now quickly summarize the pros and cons. So advantages of sharding is, like, it can handle large amount of read and write. Okay, why? Because you can read from multiple database, like, only 50% of data is in this particular DB, and 50% of the database in this DB. So write throughput actually increase. Okay, write per second is much higher. Okay, second advantage is, the overall storage increases. Okay, so if in one database you can only store, like, 1000 GB, so if there are two database, now you can store 2000 GB of data. Okay, but the complexities are, uh, creating this kind of database is difficult. Okay, why difficult? Let's say 1 is here, 2 is here, 3 is here, 4 is here, 5 is here, 6 is here. Now you want to see, and let's say there is third database where 7, 8, 9 is here. Now you want to see, like, where is my ninth number file? You search 1, is 9, 1 equals to 9? No. Is 2 equals to 9? No. So first you search this whole database, then you search this whole database, you never find this, never find this, and then you went to this and you find the ninth data. So this complexity is there. The data should be very accurately partitioned. Okay, or else you will lose a huge amount of time. Okay, so this is all about partitioning. Small description. In future videos, we'll learn more about partitioning. Thank you.